right, so this lecture video is going to go over what we can tell about an element's charge and its behavior due to charge just by looking at the periodic table. So get your handy dandy periodic table out because we're going to be writing on it, adding some more information that you already added some last week, so we're just going to be adding some things to it. We know that all of these over here are metals, and then over here are the nonmetals, correct? We learned that a couple weeks ago. So when we're looking at charges, elements are going to exist in a way that makes them stable, which really, these are the noble gases. These are the most stable, okay? And these are like hashtag chemistry goals for all of the other elements. They want to be like these elements here, which means that they want to have a full outer shell. So we can look at the periodic table and figure out exactly how elements are going to do that based on whether or not they give up or accept electrons in order to get to this particular goal, which is to be more like a noble gas. So when we look, remember, let's go reminder, we had group 1A here, this was group 2A, then we skipped over here, this was 3A, 4A, 5A, 6A, 7A, and then 8A were the noble gases. In group 1A, these elements are going to have a +1 charge to them. And the reason is that these electrons, so if you look here, they are going to readily give up 1 electron in order to be stable. If we go up to group 2A, these are going to be +2 because they're readily going to give up 2 electrons in order to be stable. Group 3A will be +3. So all of these in group 1A, group 2A, and group 3A, are going to give up electrons to become more positive. So for instance, again, let's look at lithium here. So lithium is always going to have a charge of +1 in its stable configuration. If you look at calcium, calcium will always have a charge of +2. This is the situation that makes the element the most stable. Now, we skip this row here, the 4A row, because they're going to be involved a lot more in covalent bonds without the charge. So we're going to come back over here, and everything on this side now, let's change colors, is going to want to pick up electrons, which will make them more negative. So this, in group 5A, are going to have a -3 charge. In group 6A, a -2 charge, and in group 7A, a -1 charge. So let's look at chlorine again. Chlorine, if you go figure out where it is on the periodic table, you know chlorine exists with the -1 charge. So just by looking at the elements on the periodic table, you can figure out what their charge will be. So let's go back to these. We skipped this whole section of transition metals, correct? That's because these have more than one option. So take iron, for example. Iron can be +2, or it can exist in a +3 situation. So the transition metals are going to have more than one possibility for stability. We would write an iron with a +2 charge like that. You'd use a Roman numeral, and that would, when you see that Roman numeral behind any of the transition metals, then you should know then that it's saying, okay, that means it's got a +2 charge. We would write iron with the +3 charge as iron Roman numeral 3. So by just going down and looking at the periodic table, you can tell what charge an element is going to have. Pretty slick, right?